Welcome to the stream. This is Philip Cloud, and I'm here with another episode of Philip in the Cloud. And today we're going to be talking about Ibis. Again, it's what I usually talk about. And today's topic is our new Getting Started guide. So I just kind of wanted to give everyone a tour of the feature set, kind of at a high level of Ibis. So um, I haven't actually tried to run this code yet, so we will see how it goes. I put a link to the text for the Getting Started guide in the chat, and it's also on the video description. So let's dive right in. Just a note, I will be skipping the install section, and I will do another video where I go through the various ways to install Ibis. There's really only two, but then it kind of differs between backends. So I'll leave that for another video. Look out for that in the coming weeks. That's how to install Ibis. But today we're going to be assuming that you're able to install it, and we're going to go through the Getting Started guide. So the first thing that you may want to know about Ibis is that it can work with different file types. But sort of the principal thing that it does is it connects to an existing database and it tries to interact with the data, as close to the query engine and where the data lives as possible. So, but let's sort of take a simple case, and we're going to use DuckDB a lot here. So the first thing we're going to do is just we're going to take we're going to import URL lib.request, which is built into the standard library, and then we're going to let's see, we're going to request a URL, this is all just sort of a fairly verbose way of downloading things. It's built into the standard library, so that's why it's useful for tutorials. And we're going to download this to Palmer Penguins.ddb. Cool, looks like we got that there. Let's see if we have it as a file. Nice. And if we say, it's probably just going to say DuckDB database file version 43. Great. So we've got that file there. Let's also just make sure that it's not 0 bytes. Cool. It's 1.1 megs, so it's got some stuff in there. The next thing I'm going to do is I'm going to import Ibis. After that, it's kind of really simple to just connect to an existing database. In the DuckDB case, databases are either on disk files like the one we're going to use here, or if you pass no arguments, you will get an in-memory connection, and then DuckDB will sort of operate on everything in memory. So we connected the database. Now we can see what tables are there calling this list tables method. There's one table in there, penguins. Let's pull that out because we don't just want to look at what tables are in there. We actually want to do something with it. Penguins. Cool. So sorry, I'm not following the tutorial correctly. Let's assign it the name penguins. Let's look at that real quick. So right now we just have a representation of the table. We can see that Ibis is indicating us that it's made with SQL Alchemy. Its name is penguins, and then there's sort of a list of the column names and their types. And we've got a species, an island, etc., and a couple of other interesting variables going on here. And the thing to note here is you don't actually see the data. You just see kind of Ibis's knowledge of the schema and operations that you've done. We can easily kind of start our journey by just kind of looking at the head, which you might see in pandas or other frameworks, and calling execute, which is the way that you bring back like the actual data into memory. And the thing you get back is actually a pandas data frame. We can do that again. We got back an actual pandas data frame, and so hopefully people are familiar with that. And if we don't call execute, we just get like an immediate sort of new operation here, limit R0 and 5. And the way to read this is kind of top to bottom from, like the final expression that you give. So we wrote head, that corresponds to this limit. And the first argument, R0, is just kind of a numeric alias to the thing we've limited. And the second argument is the number of rows we've limited to. One thing, or another thing to note is that you're not limited to pandas here. We have other methods like 2PyArrow and 2PyArrow batches that let you get out PyArrow tables and PyArrow record batch readers respectively for different use cases. Sometimes you'll get, your results will be much more efficient in memory if you use those methods. The next thing that's pretty neat about Ibis is that while we've been kind of looking at everything in kind of the expression tree land, we may want to actually take a peek at a little bit of the results that we've computed with our expression. And the way to do that is to set ibis.options.interactive to true. And this is a global option that will affect every expression that you evaluate in a console in a repl session, sorry. And it won't affect, like, say if you call print on an Ibis expression, it's going to do a little bit of evaluation, but you can still kind of call execute and so forth, and you won't necessarily trigger the printing kind of computation there. And so let's look at our head expression again. So you can see we've actually gotten like a pretty printed table that indicates sort of the types of the columns we've got and like the first 5 rows. And then so that's sort of the table basics, like pull a table out, or sorry, connect to a database, pull a table out, look at a few of the rows. So let's move on to like some more common operations that you might want to do, because presumably you've got some actual work you need to do, and you're not just looking at the first couple of rows of a table. When you want to filter data in or out according to some sort of Boolean condition, the way you do that is with the filter method. And so in this case, let's look at only the Adelie species of penguin. I don't know if I'm pronouncing that right. And we can kind of write an expression like this, and the results actually don't look super different from if you didn't filter on Adelie. Like if you filtered on another species, then yeah, you might see something different, or you should see something different. But in this case, these rows happen to be like first in the table, and so we only show the first 10 rows if there are more than that, and that's to prevent incurring lots of computational overhead. And if we wanted to filter like by sort of additional conditions, we can use the ampersand operator and say penguins dot species equals island equals Torgerson. Let's make sure I spell that right. And again, it looks similar because those rows are at the top of the table, on disk. And that's sort of how you do filters. The next thing you might want to do is select a subset of columns. So let's do that. You do that with the select method. So let's say we wanted to only get the species, island, and year. We only got those 3 columns. You can also select those by with column expressions themselves. So a bit more verbose, but it is possible. Basically the same thing. And then you can mix and match. You could say species, island, like this, and then you can say year. And again, these are all sort of doing the same thing. The next thing you may want to do is compute a new column. Let's say you wanted to, move move this bill length millimeter computation to a centimeter unit. So we would divide that by 10 and we'll make a new column. So the way you do that is with the mutate method. And that's actually, it comes from, the nomenclature comes from the dplyr world, from the R world. So take a look at that if you're interested. Penguins dot bill length divide by 10. And hopefully this shows up at the end. Okay, it didn't actually show up, but we can chain that, of course, with select to say bill length. Or actually, we can just select it out like this, bill length CM. Cool. We got that. If we wanted to sort of compare, then we could say dot select bill length CM, bill length and just verify that our expression sort of did the right thing. And look, it is divided by 10, so that's cool. And again, that's like you can sort of chain these things like pretty much arbitrarily, and that's really one of the powers of Ibis is like being able to compose these expressions together. Now, you may actually want to apply operations or select out categories of columns or columns based on some kind of predicate. And the way that you do that is with a feature called selectors, which is also inspired by dplyr. So let's import that as ibis.selectors as s. We'll do penguins.mutate, bill length. We'll keep this computation, and then we'll select out and we'll say, give me every column that doesn't match bill length So we're effectively dropping bill length And you can see there's no longer a bill length column in there. And the way, just to talk about matches a little bit, what matches does is it takes a regular expression and returns basically a list of all the columns that match, the column names that match that regular expression. So in this case, the regular expression is just those characters. There's also contains and a few others, and so we'll keep that at matches. And there's a separate blog post that I did on that, which I will link in the video description that talks more about selectors. You can, of course, mix and match those too. So let's say you wanted to select out island and then also all of the numeric columns. So we've got island, and then we've got maybe all the things that we care about aggregating. In this case, we also have year. So we don't necessarily want to start taking the standard deviation and mean and all that stuff of year. Or normalizing it, but we may want to use it as a grouping variable. So the point here is that selectors allow you to express these succinct ways of describing how to filter out columns by their name or some other property. In this case, we're filtering them by type in a very convenient way. There's also a link to the selectors blog posts on the Getting Started guide. Another thing you may want to do is sort by some column, and so the way you do that with Ibis is with order by. And again, we've got a bunch of columns we can select from. We're going to sort by or order by the flipper length millimeter column, and then we're going to select a subset of columns after that. Species, island, flipper length And you can see the flipper length column is sorted, and these other columns are not sorted. If you wanted to sort in descending order, you can call the desk method. Now we have the largest values of flipper length at the top, and you'll see that nulls are sorted first by default on the DuckDB backend. We don't yet have an API in Ibis for controlling where nulls appear in sorted output. If you're interested in that, we could add it. We just haven't done that work yet. Please get in touch on our issue tracker if you're interested. If that's not convenient enough for you, you can call this Ibis desk top level function, and you can give it a string. And that will have the same effect. So that's sorting. The next thing you may want to do is aggregate data. Presumably, you don't just want to do filtering, selecting, and mutating. You actually want to sort of summarize some data in some way. Um, in this respect, Ibis looks a lot like pandas and NumPy to some extent. There's methods on its columns that sort of give you, like just sort of do the compute for you. Um, and one thing to note here is like this is actually an expression. It's not actually a computed number. If you want to get the floating point value out, you call execute. And you can see this is probably a NumPy float 64. Great. And if you want to aggregate multiple things, you can call aggregate. You probably saw an alias pop up there. Ag is just a shorthand for aggregate. It can be a little bit more convenient to type ag if you're in an interactive session. So here we can say penguins, flipper length, and now I'm going to start to use more tab completion just so I don't have to avoid typing everything. Bill length, dot max. And Ibis will automatically sort of name columns for you based on the computation that you did. Here we're just taking the average of flipper length and the max of bill length, so it's stuck kind of automatic names in. There are APIs for naming, for naming sort of as you like. If you wanted to name your column, you could say like, max bill length or something like that. And then that appears as the column name in the output. But really where sort of things start to be nice is when you need to group by things. And of course, that's not super different from other APIs. We've got a group by method. We're going to group by species. And we'll just call aggregate. It's like this is a little weird, but like it's kind of an interesting thing to look at. What happened here? What happened was there were no aggregates, but we grouped by something. And so this is sort of kind of a goofy way to write like a select distinct, if you're familiar with that from SQL. So it's not doing a whole lot. And in fact, if you look at the SQL for this, it's basically just what you might expect from a distinct. We're grouping by the columns, but we're not aggregating anything, so we're just getting the unique values of the grouping keys. And this works as you might expect for other things. Group by island and aggregate. Another way you can write this is is just calling kind of distinct on the on the columns like this. Right, you get the same answer. Unclear, which one you should use. It sort of depends on your use case. Moving right along, let's actually aggregate something instead of just showing ways to compute distinct columns. So you can stick an expression in here, bill length dot mean, like we had before, and now we've actually done the summarization. Again, you can always look at the SQL of an expression for a SQL backend anyway, using ibis.showSQL. In this case, we're kind of generating what you might expect to write by hand. And aggregate, as we saw before, accepts multiple aggregations. Flipper length dot max. Saw the SQL there. Let's actually look at what the result looks like. Cool. And then we can get, you can kind of drill down as far as you want. If you wanted to add the sex column to look at the different penguins' sexes, you can do that too. Now, the whole point of all these different APIs is that to provide you with kind of the building blocks of each component of your analysis that you might need to do. Not necessarily that your component is going to be like a specific or like a global task. It's basically like I need to analyze some data. I need to answer this question. So I need to group by and then aggregate and then join and then select and then filter, etc., etc. Each of these pieces is a single component that you can chain together with the other pieces. And that's kind of an explicit design goal of Ibis. So let's do some of that. Let's see what the largest female penguin by body mass was on each island in the year 2008. This is just straight off the getting started. Straight out of the getting started doc that we have, which will be landing. It's already up in the documentation, kind of officially released in 5.1. Sorry, not group by. Getting a little distracted. I'm going to do penguins.sex because we're looking at the largest female by body mass. I can spell 2008. Oops. 2008. We're going to group by island. Oops, island. Cool. And then we're going to aggregate. I'm going to use ag here just to keep it a little bit shorter. Penguins dot body mass g dot max. Cool. That was the answer to our question, which was what was the largest female penguin by body mass on each island in the year 2008. We've got on Island Bisco 200, etc. And then we can also, what if we wanted to know the largest male penguin by body mass on each island for every year of data collection? So in that case, like we wouldn't want to necessarily filter by year, right? So we'd say, we want to look at males. We want to get rid of the year filter. Let's get rid of this extra parentheses. We don't need that either. We're going to group by island and year. And then for the aggregate, we're going to keep body mass max, but we're going to name that. And you can, there's a couple of ways to name things, not many. I think it's probably 2 or 3. It sort of depends on what you're doing. But for interactive analysis, it's often convenient to pass the name, equals the expression as Python keyword arguments. And then we're going to order by year and max body mass. Max body mass. Okay. And there you have it. We've first ordered by year and then ordered by max body mass, and we can see the answer to our question about the largest male penguin. If you're interested in learning more, check out the link. I will just paste it here in case people want to see that in the video. It's also going to be posted in the chat and on the video description. And we also have a series of more in-depth tutorials going over kind of deeper dives into specific aspects of Ibis that you might be interested in. So thanks for watching and hope you enjoyed the video. See you next time.